Hello everyone, welcome to another National 5 trigonometry video lesson. This will actually be the last trigonometry video lesson that we do because we're at the end of the unit. Let's have a look at the outcomes. So we've done all the ones you can see on the screen here. We've done the area of a triangle, the sine rule for finding sides and angles, and the cosine rule for finding sides and angles. So basically you now have a complete toolkit to go on and complete, any question that's put down in front of you. So this video is really going to cover these last two bullet points. I thought it'd be good to just get it all over and done with in the one video. So we're going to first take a little look at a strategy. So how do we decide? How do we look at trigonometry questions, and what information should we be looking out for to help us decide whether to use the area of a triangle rule, the sine rule, or the cosine rule? And I've got some tips and tricks and some things for you to jot down. The last bullet point is about solving trigonometry problems involving bearings. Now, the reason why I didn't want to do that as a video on its own is because you've already been developing that skill across all the exercises you've been doing already. So what I thought I would do is I've got the last example that I'm going to do in the video is going to be a past paper question that involved, actually it's not the last example, one of the examples that's coming is going to involve bearings, and I'll talk you through all the kind of ins and outs of it then, and then that can be like the example that goes with that, rather than doing another video for it. Because as I say, I've already actually done a video on a couple of bearings questions that I posted for one of the exercises before. So let's get going with this. Right. Now, I suggest on this page you jot down, if not everything that you see, certainly some very crystal clear notes on it. There's only 4 bullet points here, if you like. The first 2 you can see on the screen just now, but this is the strategy. This is the kind of thought process to go through, right? And the way I kind of approach these problems is, well, what can I rule out? Because sometimes it's quicker to rule strategies out than it would be to run through them all and things like that. So first, the first one to rule out very, very quickly is the area of a triangle. Is the question to do with areas? If it is, use that formula. If it's not, don't use that formula. It's pretty much that simple. For number two starts to rule out the cosine rule, because again it's a little bit easier to rule out the cosine rule than it is to rule out the sine rule. So if you look at the question, if you look at the triangle that's within the question, you might have to do a little bit of work with the triangle first, but when you're confident you've got all the information, if you have this scenario, if you have 2 sides and the angle in between them, so on the picture there I've got 10, 12 and 30 degrees is the cosine angle in between them, and we're finding the side opposite. If you've got that scenario, then use that version of the cosine rule, right? If not, don't use it. Like it's not, it's that straightforward. If you have that, use the cosine rule. If you don't, move on, right? Number 3 is to do with is the other version of the cosine rule, and again it's nice and quick to rule that one out as well, because you can only use that version of the cosine rule if you have all 3 sides for finding an angle. So again, if you don't know all 3 sides, don't use that version of the formula. And so basically, if you've ruled out the cosine rule and you've ruled out the area of a triangle, then this must have to use a sine rule question, right? Now, it's that sort of straightforward, so you'll hear me when I go through the examples, you'll hear me talk through these 4 things, and I'll start ruling things out, and I'll sort of try and talk out loud what the thought process should be, so that you're modelling that when you're sitting down to try these questions on your own. Okay, but it is just a kind of simple ruling out process. Now, it's not perfect, because some of the questions rely on you finding out some information about your triangle first, for instance. So some questions you might need to find an angle that you need to use. You might need to, you know, do some work with some bearings and things like that. So you might not have all the information to start with. But once you're as sure as can be that you have worked out all the different um, parts of information and you've got everything that you need, start working through this process, right? And then at the end of the day, you'll probably still make plenty of mistakes with this in terms of selecting the wrong strategy or not quite knowing how to get all the information, because at this stage, every one of these questions is different. So you only really get better with this if you know through experience by doing as many of these kind of questions as you can. So don't worry about it. You know, if you're sitting down to do a question and you can't quite work it out, you know though I've put a kind of clear strategy here in front of you. Sometimes it's not always that straightforward. Drop me an email and ask. Now, let's maybe look at the first example. Now, what I'm going to offer you is you might actually want to give this question a go. You might want to try and work it out before I go through the solution. So if you want to pause the video and have a go at it, see if you can come up with the right strategy and the right answer, go for it. I'm going to run through it anyway. This question is or all the three examples that I'm going to do here are all past paper questions. They're all from National 5, Credit or Intermediate 2 past papers. So these are all exam level examples, right? So they're well worth taking a note of. So pause the video, see if you want to have a go. Okay, let's have a little look at the solution to this. So faced with a triangle, it's a fairly plain triangle. There's no context to this. Sometimes there's buildings and boats and helicopters and all that kind of thing. So nothing to sort of sift through there. Three vertices, E, D, and F, and all three sides. Right. So calculate the size of angle EDF. Now, one of the first things I would usually do is mark that angle on there, because if you don't mark that angle on there, then you're going to run the risk of in a couple of minutes time having forgotten which angle you're after, and that's when you're going to start making mistakes. So try and work really methodically and really clearly to yourself. Now, start running through things to rule them out. Is this an area question? No. So I'm going to use that. Do I have two sides and angle in between them? No, because I need to find this angle at D. Have I got all three sides and I'm finding an angle? Yeah, I do. 19.6, 10.4, 13.2. Yeah, I do. So I'm going to use that version of the cosine rule. And it's that simple to use, guys. Right? So let's pop together. Let's write down our formula. Now, check the formula sheet, right? There is nothing I hate more than sitting down to mark somebody's work, right? Or even particularly when it comes to marking the exam papers. There is nothing I hate more than sitting down to mark somebody's work and they're doing a question and they get the first mark lost because they've copied the formula from the formula sheet incorrectly. Like, I just feel like that sort of thing is just inexcusable. So take your time, right? Look at the formula sheet and just get it copied, right? Don't panic about it. It's there for a reason, right? And it drives me nuts when folk either forget to look because they think they've memorized it or they just copy it wrong. So we need our cosine rule formula for angle D here. So this is cos D equals E squared add F squared, take away D squared, all over 2EF. Okay, so pop in the numbers. Right, 13.2 squared plus 10.4 squared, take away 19.6 squared, all over times 13.2 times 10.4. Happy days. So get a new line, cos d then. Now cos d is an obtuse angle, right? We know that because it looks, well, the first hint is it looks like an obtuse angle, but it's also the angle opposite the biggest side, so it's probably quite likely an obtuse angle. So we would maybe expect a negative value here, remember, okay? So when we pop this through the calculator, then we can put all of that in the calculator and on go, you get negative 0.3706. So that kind of fits with what you thought you might get. D then is the inverse cos of this, and that comes to 111.8 degrees. Okay, so problem solved. Calculate size of angle EDF, job done, 3 marks. All right. So as I say, not too bad if you can. That's a fairly plain box standard one. You would usually find that one quite early on in the exam paper, because it's fairly routine. You just have to decide the strategy for yourself. The next two examples aren't quite so routine though, and these will start thinking about your problem solving skills. Okay. Particularly when they involve bearings, right? So let's have a look here. Always read the question, right? Read it twice if you need to, and as you read it, annotate the diagram, right? If you don't have the benefit of the diagram, I do obviously because it's on my laptop here in front of me, but if you don't have the benefit of the diagram, draw it out. You've no idea how beneficial working with a diagram, particularly your own diagram, is going to be. So read through the question. David walks on a bearing of 050 degrees. Right, well that's this angle here, isn't it? Right. David walks on a bearing of 050 degrees from hostel A to a viewpoint V 5 kilometers away. Right, cool. So I've identified that. Hostel B is due east of hostel A. Now, hostel, this piece of information here, this sort of thing is quite common in bearings question. One point is due east, due west, due north, due south, all that kind of thing. These sorts of information can be quite common because they're there as a big clue as to how you're going to work out the angles within the triangle. And that clue there, that I've put the box around, is your first clue to working out angle A. Yeah, because if B is due east of A, then this has to be a right angle from the north line to B. So if that is a right angle in there, and it's 50 degrees to here, well here must be 40 degrees. Right? And that sort of thing to look out for is quite common in a lot of bearings questions, okay? So on angle B, right, if we read through the next part of the question, Susie walks on a bearing of 294 degrees from hostel B to the same viewpoint. Now, for that sentence, you need to put in a bit of information yourself. So we've got the angle at B to calculate here. Now, the first thing we do is stick on a north line and pop on that bearing of 294. I've drawn that in the wrong place. Right, pop on that bearing of 294. Right, so that's 294 degrees from the north line all the way around to the line that takes you from B to V. Right, because it's what it is it's from hostel B. So that, imagine yourself standing at point B facing north to the viewpoint. That is the bearing from B to the viewpoint. So if you're standing at B facing north, then you would need to turn through a bearing of 294 degrees to face point V. So remember, bearings are always measured clockwise from north, right? Even although it would be clearly more efficient to go that way, bearings are always measured clockwise from north. So that's 294 round to there. So we've got an opportunity to work out this angle here, right? Because from the north line, round to the line that takes you from B back to A, that has to be a bearing of 270. Like it has to be, because A, if B is due east of A, then stands to reason that B, no, not B, A would be due west. Yeah, so A is due west of B, right? If B is east of A, then A must be west of B. So that means that from, we've now got 270 to this line, 294 to this line. So this angle in here must be the difference between 270 and 294, so 24 degrees. Okay, and that's how to work. That's how to work with the sort of bearings scenarios. There are other questions that I can remember from past papers of old that involve a little bit more, but you kind of, that's the gist of most of them, trying to look for little hints and clues that are going to help you find missing angles, using a lot of your angle knowledge from first and second year. So what's the question then? Calculate the length of AB, that's that side of the triangle, the distance between the two hostels, right? Okay, so let's start running through all of our strategies. Yeah, so the first one's areas. This is not an areas question, so we can rule that out. Cosine rule for finding a side. Well, have I got two sides and an angle in between them? Well, no, I've only got one side, the 5 kilometres. That's the only side I know. And I have to calculate the second side, so I'm not going to be able to use a cosine rule. The alternate form of the cosine rule as well gets ruled out because I've not got all three sides and I'm not finding an angle. So this has to be last, last and least. Well, must be a sine rule question. So let's have a little look. Write out the sine rule. Now I'm finding a side, so my sides go on the top. Yeah. Remember, if it was a sine rule question, you're going to find an angle, put the angles on the top, sine A over A, and so on. But since I'm finding a side, I'll do A over sine A equal to B over sine B equal to V over sine B. Right, happy days. So, what do we know? Well, we know the angle at A, we know the angle at B. I want to find the side V, and I know the side at A. So I've almost got a complete pair where I know 3 out of the 4 parts of the information. Ideally, because I'm wanting to calculate V, I need to use this one, but I could do with the angle here. Well, I know 2 of the 3 angles, so I'm going to up here, I'm going to say angle AVB is 180, and you've done ones like this before in the exercise, where you have to find the angle first. 180 minus 40 minus 24, and that comes to 116 degrees. So I now know that angle. Happy days. So, what I'm going to do, hang on, I've ticked the wrong letter there. Let me fix this. Mistakes happen, see? So, that's side A, but it's side B that we know, so it's actually that one. Right, so we know all 3 angles, we know side B, and I'm calculating side V. So, using B over sine B equal to V over sine V to find the answers. Okay, so B is 5, so that's 5 over sine 24 equal to V over sine 116. And hopefully you're remembering how to solve it from here. Times by sine 116, both sides. And we're going to get 5 times sine 116 over sine 24. Remember, be careful when you're popping this into the calculator, close all the brackets that will appear around the angles, right? Otherwise you'll get math errors. And if you pop that through the calculator correctly, you get V is 11.05 kilometres. Okay, so the hostels are roughly 11 kilometres apart. Alright, so there's a lot more work. Look at the mark count though. The last question was worth 3 marks, this is worth 5. Yeah, so there's quite a lot going on here. You'll get process marks for all the angles work and things at the start, and it's usually 3 marks for the trig process at the end here. Okay, so it would probably been somewhere in the region of the first mark for 40 and 24 degrees, the second mark for the 116, and the third, fourth, and fifth marks for the sine rule process at the end. Okay, last example, folks. Let's have a look. Okay, now you need to pay very careful attention to this one um, because here it's here. This one involves a little bit of extra work at the end of this. It's still only worth 5 marks, but it's quite a tricky one. And you can see that actually, even just looking at the text involved in the question, there's a lot of text to read through. So let's just read through the question first, right? The diagram shows 2 blocks of flats at equal height. Okay, happy with that. A and B represent points on the top of the flats, and C represents a point on the ground between them. To calculate the height h of each block of flats, a surveyor measures the angles of depression from A and B to C. From A, the angle of depression is 38 degrees. From B, the angle of depression is 46 degrees. The distance AB is 30 metres. Calculate the height h in metres. Now, a couple of things to deal with here before we start getting into solving this question. First of all, the phrase angle of depression is one you should remember from S2. You might not. If you don't worry about it, but it's kind of marked on the diagram really for you anyway. But an angle of depression is an angle from the horizontal looking down the way. Okay, so if you were standing at point A here, then your eye line would have to go from the horizontal down 38 degrees to be looking at point C, and that's an angle of depression, right? You might be more familiar with angles of elevation. That would be the opposite, the angle you have to turn through to look up. So these are angles of depression. Now the last thing I want to point out before we get too far stuck into this question is this height h of the flats. Now what I'm going to do is move that over into the triangle, and what you'll see is this here, right? That is that height line, the height of the flats. And bringing it inside the triangle has benefits that we'll talk about later on in the solution, okay? But it's quite common to be marked, for that to be marked away from the triangle, and you have to kind of sort of visualize it yourself and put it in. So we've got centimeters, we've got 2 angles, and we need to find this height in the middle. Now, what's different about this question to the other two is that, and in fact in any other trig question you've done so far in this unit, is that you've always found out a part of the triangle. You've either found one of the 3 sides or one of the 3 angles. This height here is not part of the triangle, right? It's essentially not part of the construction anyway of that triangle. That h line is what I would often call an altitude of the triangle, and it's quite handy because it makes right angles with the base. Okay, so if it makes a right angle with the base, then that's quite handy because that makes my triangle into 2 right angle triangles. And that's going to be important when we get to the end of the solution. Okay, so let's have a little look at what we can do here. The only thing we can really do is we could work out the third angle at the top here, because I know the other 2, and we could work out either of these sides, and what I'm really doing there is just kind of playing the game of what is there to work out, because sometimes it's not that obvious what you have to do, especially in a question like this where you're not finding a part of the triangle. You're looking at this and thinking, well, how am I going to get that middle height there? I can't use any trig to get that. Well, what is the question's not impossible. What is there to work out? Well, there's an angle there to work out, and there's two sides to work out. So we just kind of have to pick something and kind of go with it. Um, let's start with the angle of C. Let's work that out. Angle ACB is 180 minus 38 minus 46, and we get 96 degrees. So we now know the angle at the top. Right, well, that's fine. Okay. Here you've got the choice. If you were to look at finding x, right? So if we were to look at finding side B, if you like, well, there's not two sides and angle in between them. There's not all three sides. It's certainly not an area question. So that's a sine rule question. And I could use the sine rule to work out x. But at the same time, I could use the sine rule to work out y. And in this sort of question, it doesn't matter which one you work out, right? It wouldn't matter. Both of them are going to help you when we get to the end. And I'm going to hold off telling you what I'm going to do at the end until after I've worked out one of these two sides. Okay, so just bear with this solution a wee minute. I'm going to choose to work out y. I'm going to find side A. So I'm going to write out the sine rule. So it's A over sine A equal to B over sine B equal to C over sine C. And A is what we're trying to calculate. I know all three angles, so I'm going to tick all of them. And I know side C. So there's my pair. I'm going to use the A and C's. So A is what we're trying to work out. A over sine 38 equal to 30 over sine 96. Okay, multiply both sides through with sine 96 and we'll get A equal to 30 times sine 96 over sine 38. And so A is 18.6 meters. Now what I'm going to do is just update my diagram. Right, 18.6 meters. Now that's fine. So we've done the sine rule process. We've worked out a side, but we still don't have what the question's after: the height of the block of flats. Now, if you break this down, let's revisit what we said before about this altitude line splitting the triangle into two right angle triangles. If I just peel off the right angle triangle that's on the right hand side here, the one involving 18.6 meters, if I peel that off and let's draw it. There's my right angle, there's C, there's B, there's my 18.6 meters, and there's my 46 degrees. I don't know, because this triangle is not symmetrical, I don't know what portion of the 96 degree angle would sit in here, so I wouldn't fill that angle in, right? But it's certainly not half 96 because the triangle is not symmetrical. Now, last thing, there's H, here's what we're trying to find. Now, that triangle should look pretty familiar because we spent a lot of time at the end of S2 stroke the start of S3 doing trigonometry for right angled triangles. And this question, this sort of question, where you have to find the altitude or the height of the triangle, involves you having to do a sine rule or cosine rule process to find a side and then use that side with a right angled triangle that makes up your overall triangle, and using SOHCAHTOA to get to the end of the process. Okay, so what we've got here is we know the hypotenuse, right? We want to calculate the opposite side, remember the opposite 46 degrees. So tick the O's, and we have to use the sine formula. So sine 46 equals the opposite side over the hypotenuse, And so the height is 18.6 times sine 46. And here we get our final answer, 13.4 meters. Okay, so it's quite a long process to get to the end here, right? But that is our height. Okay. Now, one thing really just to sort of sum that question up, almost kind of, if you like, almost kind of think of this as your like an extra. You've got your plane triangle questions where it could be areas, sine rules, or cosine rules. You've got bearings questions where you have to do a little bit of angle problem solving, and then you've got this one. This is like an extra one to kind of keep in the back of your head. If you have to find the altitude of the triangle, right, so the height of it, do a sine rule or a cosine rule process, find one of the sides, and then identify a right angle triangle in your diagram, and use SOHCAHTOA to get a solution. Okay. Now, I'm going to finish the video there because I've just noticed it's now just gone over half an hour. So hopefully you've been patient enough to get all the way to the end of this. Sorry this one's so long, but hopefully you found it very useful to get all the way through to the end and see all the different types of exam questions that could come up. So you've really kind of got three. You've got your plane triangle types. You've got your sort of bearings questions and questions where you need to do a bit of angles work first, and then this last one here we need to find the altitude. I'm going to set you the last couple of exercises out of the book, so however you check in the Google Classroom notification for the work, and I'll give you plenty of time to get through this. Try and make sure you do get through as many of the questions as you can. You only get better with this through experience, so do as many questions as you can. You're going to have plenty of time to do it, and as ever, drop me an email if you need any help. Alright, thanks very much.